Okay, so there's some code that I've written for social network analysis, and this is not necessarily a social network which is there on, say, Twitter or on Facebook or something to that effect. There is some Excel data that we have, some CSV files that we have, which are basically a social network of students in a particular university, in a particular college, and that is what we are trying to analyze. So without much ado, I'll straight away get into this. So there are three packages that I am loading, and before I do this, let me clear my environment, and let me also clear my plots. Yeah, okay. And of course my console has some, but I'll just let that be. Okay, so here are the three libraries that I'm using. These are SAND, RGL and igraph, and as and when the functions get used, I'll keep on getting into this. And firstly, we want to create a simple graph. A graph is basically a network in network analysis terms. So a graph is a network, not necessarily a social network, but a network of nodes or vertexes. So the vertex or the node could be an individual, a human being, could be a website or a blog, or could be absolutely any other entity which has got some kind of communication link to another similar or in certain cases dissimilar entity also. So here's the first graph. Let's look at this graph that we've created. And what is mentioned over here, it says 1-5, 1-7, 2-9. So that is basically showing as to what is the linkages that we want to be there in the graph. So if you look at the console now, and let me enlarge this, not looking at whatever is above here but down here, what it shows us is that it's igraph. So that's the class name, and it's been created by the library igraph. So it's a function of igraph. And then there are certain vertex names. So these are the vertex or the nodes and their names. And the edges, these are the edges and not the vertex names. The vertex names are 1 or say 5 or 7, 2, 9. So whatever numbers that we've kind of given them. Let's try out another one, and let's say we change it and we call it graph 2, or maybe graph underscore 2, and we go ahead and change the relationship. We put a 7 here, we put a 11 here, and make sure then we go ahead and put some kind of relation between, say, 9 and 11 also. Otherwise 11 would stick out like a thumb over here. Okay, so let's go and do this again, a similar output. So this is how you basically create a graph with the package igraph in R. And then let's go ahead and look at the vertex sequence. So what I was doing over here, I was just going ahead and printing this by executing this say one alphabet code. Now what I want to do is I want to take a much more structured approach to this and look at the vertex or the nodes. So it says there are 9 vertices and it lists them out over here. So 1, 5, 7, 2, 9, 4, 3, 6, 8. And similarly, if I were to go ahead and let's say I copy this entire bit and I bring it down here, and I want to do something similar for my graph 2 that I created right now. So we can go ahead and do that also, and let's see what is the output that we get. So this is my the first graph, and this is what I get. And if I want to save this, and what you can see is that there are some connecting lines or certain edges which are there, but these edges do not have any directional arrows, so they do not have any arrows at the end of the edges. These are just lines which are connecting from one vertex or one node to the other. And if I were to go ahead and save it in a PDF, what I could do is I could just go and choose this and say G and save it, and it would pop up on my screen and nothing fancy would happen. I would just go ahead, zoom in, have a look, say okay fine, this is what it is. But what I can see is that this particular line has got no arrows on it, right? Because when I zoom in over here, I can't necessarily see that. So on the PDF file, I can easily zoom in and see that this is non-directional linkages over here. So there is no direction to these linkages or these edges. Okay, so similarly, I go ahead and look at my, I go ahead and look at my second graph. And when I look at my second graph, again similar, but because I added 11 over here and I added some other relations, so it looks slightly different. We are not saving that in the, okay. Now what I want to do is I want to create a 3D plot of this. You might ask me why. Okay, maybe just for the visualization, if nothing else. It looks slightly much better than the normal 2D plot. And let's say we create a 3D plot not only for the initial graph, but also for the graph that we created right now. And we say, okay, this is what we want to do. And fine. So this is a separate pop-up that comes up in RStudio, and I am using Windows. So this is what it looks like. And if I enlarge this, it says RGL device 11 and then focus. Why it says 11? I think because I've been using it for a while and I have not restarted R, so it's gone to 11. Otherwise, it was showing me RGL device 1 initially. Okay, so here is the graph. So you don't get to see anything. You don't have the nodes numbered or labeled. You do not have the vertex or the nodes which is these numbered or labeled. But yes, you can drag it around. You can play around with it. There are various other things that you can do, and we will realize once we have a larger graph, which we will see later, that a 3-dimensional graph is pretty much okay. It's actually much better than a 2-dimensional one when you want to analyze it visually, that is. And let's look at this. How different is this? Again, slightly different. Hardly anything you can make out. I can't even make out where that 11 is, wherever that is. Okay, we'll just let this be for now. Okay, now fine. So here is another way of creating a graph wherein you use make lattice, the function make lattice which is there, which is again part of igraph, and you create some coordinates and you pass those coordinates to the to the 3-dimensional plot. And what I'm doing down here is structure G1, which is the same as if I were to just go ahead and do G1. So let's just try this code out. Let's see what happens. Okay. So this is what the graph looks like. So let's go back to the code and then visit this again. So the code says make a lattice of 5 into 5 into 5, which is create a row, create say, in vector terms probably create a row or a column vector with 5 nodes and another one and then create a lattice of all these 3. So you go ahead and combine these and you create a lattice of all these 3, and then you pass the coordinates and you want a 3-dimensional one, and then you go ahead and plot it with the coordinates. So this is what is happening, and now this is much more let's say it's just more fancy looking, but it does not necessarily show you anything as far as relationships are concerned, because now over here, if you were to consider, say, these three over here, these two are equally connected to the one on the corner, the cornermost, as are this one and this one. So okay, let me try and see if I can catch hold of these numbers for you. So there is 5, 4 and 10. You can see the 5 here, the 10 here and the 4 on the left side. And you can also probably make out that what we have over here is 9. So 9 is equally connected to 5 as is 4 and 10. So this graph doesn't necessarily tell you much. So unless of course it's created in a different manner, this graph is just a fancy three-dimensional lattice that you can play around with. And you see on top RGL device 13. So how many times I go ahead and run this device, it goes ahead and numbers itself according to that counter. So again, let's just go ahead and okay, now here is something which is a little bit easier to understand and analyze. So the point that I was trying to make was that if you look at these three vertices over here or nodes over here, you can't necessarily make out as to which is connected to which one, or what is the information gain or whatever is the information loss, or how of course the one in the middle, which is 4 over here, is centrally located and is connected to how many? 1, 2, 3, 4, 5, 6. So he's connected to, no, not 6, 4 and 4, 8. He's connected to 8 over here. So which maybe we could say is much more centrally connected and is probably acting as a bridge within this network to pass information from here to there. Whereas this one is also acting as a bridge, but only between say 3 nodes. If you were to take this corner node, which is what I can't see the number on this. Any which ways. So we'll skip this also. So this is just a fancy way of looking at the graph, but it's not very intelligent as of now. So there's nothing very intelligent that is happening right now. Okay, so let's now create a graph which has got specific labels and is a directional graph. So the graph formula remains the same. Sorry, the function remains the same, but the parameters and how they are connected, so or rather the nodes or the vertices and how they are connected to each other, what I have given over here is a minus and a plus. So which means there'll be a unidirectional or a one directional information flow, or say some kind of directional edge which will exist from Sam towards Mary, okay, and similarly from Sam, say, towards Tom, and between, say, Adam and Sammy, again unidirectional or one directional, and again between Jake and Brian. So let's go ahead and plot this and have a look. Okay, so this is not a complete graph, or this is not a complete network. It has got 3 different networks which are there, and as you can see over here, I can't necessarily zoom in without losing focus on all of them, but once I zoom in, you can look at these arrows, and because I have not gone ahead and labeled the names as yet, and which I realize now I should have, it's possible to do that. You see from this particular node, the arrows are flowing out and are rather moving out in this direction and are connecting with these 2 particular nodes. And again, from this particular node, information is flowing only in one direction and not in both the directions. And similarly, if you were to look at this one, which is sorry, yes, the labels are there. The labels are there. The names are visible. So let me look at this particular case of Jake and Brian. So this one's Brian and this one's Jake. And let's zoom in over here and hope that we don't lose focus. Okay, so we can still make out that this one's Brian and this one's Jake. So from Jake to Brian, the information is flowing because you can see the N over here. So this one's Brian and that one's partially, that's Jake. Okay, so going back to the code, from Jake to Brian. So whichever side has the plus sign on it, which is Brian over here, the information is flowing in that direction. Okay, skip to the next one. What happened? Okay, yeah, sorry. So again, this one is further connected. It's not like the earlier one, which was highly disconnected. So this one is further connected, and we can see that Brian and Jake are here, and then Jake and Brian are here again. So we've got this slightly intermingled names over here with yeah, Jake turning up twice. Yeah, but anyways, so here again we can see the same thing, that the arrows show us flow of information, or the flow of the connection that is there. Now moving on to some source that I have picked up from stanford.edu, and I have kind of picked it up today only, so I am saying forked as in on 4th September. I have not necessarily forked it. I have not gone to their I've gone to their GitHub and just copy pasted it from there. So I'm not necessarily forked it on GitHub. That's not what I've done. And of course, I'm citing the source. It very clearly says that it is from the Social Network Analysis Labs in R at the Stanford University. And this is a 2010 this thing which is there. Okay, now getting down to their code. Now I don't necessarily know why they call this Mag Act 96, but I'm presuming it's got to do with some particular batch of students or something to that effect. And this is the URL for the text file, for the code, for the data file, for the data that we are going to import. So this gets imported by this read.delimited, and then of course the NAs we want to do away with, NA strings, and we want to not check names, so the check names is not running. So this is what we get. So once I have run that one line of code, okay, it took a slight while. So this is what I basically get. I get a data frame with 95 variables or 95 columns and 1295 observations. So not all observations are shown here, only 1000 are shown here in this particular screen, and the 95 variables are surely visible. So what are these variables? Let's just quickly go through that. It's ID, the IDs of students, so those could be roll numbers or class IDs, and then there is gender, there is grade, I presume, and then there is a race. Okay, so I do not know. Okay, any which ways. Then they have the Asian club, the Hispanic club, the Latin club, the French club. So basically this is this is opportunity for networking, so to say. So if you can see this Latin club over here, you see that three of these folks, which is the second record, the second, third and fourth record, or the second, third and fourth row, are part of the Latin club. And if you look at if you look at their race, so it doesn't necessarily make sense. But any which ways, so maybe whatever this coding is. And then there is the German club, the German NHS, and so there are various things over here. There's wrestling, basketball, cheerleading, and all kinds of activities are there which these students are part of. So we'll just let this be for now. And similarly, you can go ahead and import these two also. I shall not be using them in my analysis. So what I'll go ahead and do is I'll just let them be here and not necessarily bother about them later. So what I have done is I've gone ahead and written CSV files of these, and I have saved them in my current directory. What I'll do is I'll run one of these and show you as to how that is done, but I will not go ahead and do that again. Okay, now this is my desktop. Okay, yeah, this is the one. So this is basically the CSV which I have downloaded. So you have to go ahead and adjust the column headers. And this initial column, which is serial numbers over here, is not necessarily part of the initial data frame which you import. So what you can do is you can safely delete that and just save this CSV. So it's a replica of what you've imported, and we'll just let this be. Now what is happening over here is you are going ahead and okay. So what I've also done is I've gone ahead and truncated two of these, or rather one of these data frames, and I've done that in a roughshod manner in the CSV file itself. Let me show you those CSV files. So I've just gone ahead and deleted some records. If you look at this, in place of 1295, there's just 501 rows over here. So which is basically 500 records of students, and I have created another one which is just 100 rows. And the reason I have done that is because I want to reduce the not necessarily reduce the dimensions, but just go ahead and reduce the amount of data that we are playing around with, so that, and let me import both of these now. Okay. Now this is exactly what I've picked up from Stanford, this code, and what we are doing is we are going ahead and creating attributes structure, which is right here. Okay, so this is a data frame with 4 variables which has been created from the raw data that we input right now. And this is basically picking up the demographics, so to say, of the students, and it is not picking up any of the other observations. So it's not picking up the binomial 0101 for the or the what should I the factor, this thing. It's not picking that up. It's picking up the rest of the initial 4 columns. And similar attributes I go ahead and create for the truncated data also. So what this code basically says is you go ahead and pick up whatever is there in column 1 to 4 and don't pick up the rest of it. Then we want to drop these columns from the actual data set, and again we want to add the row names. Now this is actually wrong. It should be, we should not be using equal signs. Any which ways. So now for future reference, they say that this is stored in the package net data. So again, I'm just keeping this for reference sake. We probably won't need that because we've downloaded that in the CSV using write table that we've done that. Okay. Now repeat for truncated data MG96. So this MG96 is the data set that I've created with the 500 variables. Now what I'm doing is I'm going ahead and again doing what I did earlier for the complete data set for the two of these. And now let me show you what this looks like. So if I go ahead and look at my G96 now, so it's a large matrix. Okay, one second, let me not look at G96, let me look at MG9. So this is 100 observations of 95 variables, and this is a manageable data set for basically the network analysis that we want to do, and especially for the visualization piece that we want to look at. So this is what we'll kind of focus on, and the rest of it, which is the larger initial data set or the one that we created with 500 observations, which is this MG96, we will not necessarily look at this much from a visualization point of view. Okay, so now coming down to now creating the graphs out of this. Now this is the initial data that we've imported. That is one done, and we want to plot this. We also want to look at the structure of this, and the plot shall take a minute to come up, and this is what the plot looks like. Very, very unintelligent. You can hardly make out anything. There's you see swim, basketball, student 12th, girls 8th, something. So there's not of much use. Anyways, so let's create one similar one for the data set that we created with just about is this done? Yeah, with just about 100 observations. So this is much more, you can make out as to what is happening. And if you look carefully, you can also, let me export this to PDF. You can also see, let me just call it 2 for the sake of it. And if I zoom in over here, you can make out that there are edges which are connecting these nodes. You can see them gray over here. I have not changed any colors. I have not done anything. So this is the default which is kind of coming out. But this was not possible with the initial data set. So we've gone ahead and reduced the size of the data set. And again, you have to zoom in, do all kinds of funny things to get to see as to what is happening. And this is just with 100 observations. So if you had less than 100 observations, then probably it would be more intelligent, but then in any which ways, it probably won't make sense to have a network with less than 100 nodes. So look at a shorthand to access edge or vertex node attributes works. So it's similar to looking at one particular variable name or looking at one particular column within a data frame or a list object within a list. So, and again, the edge attributes and the vertex attributes can both be discrete or continuous data types. So we'll come to this later. Now we go ahead and do some changes in the color. Now this code can sometimes go a little bit wonky. So what you see over here, this number 1295 is basically the number of observations that we have here. Which you can see right here. It says 1295 observations, but sometimes this does not run properly. So let me just hope it does now. No, it doesn't. Right. So if I change this to 1294, I presume it will run. And I have absolutely no idea why this is happening, because last time I changed it to 1294 and I tried to run it, it gave me the same error. And I changed it back to 1295 and it ran. So I'm not very sure what exactly is happening here. But anyways, I need to see this further. And this is a known error. So there's it's all over Stack Overflow and other sites. So we will not bother about it much right now. Okay. Now what we see over here is that the vertex 1 or the node 1 has been allocated this particular color. Now whatever this color is, we will not try and get into that, because this is, as far as we are concerned, this is pure red. But I couldn't necessarily place this particular notation for RGB what I could place was hash FF00, which is given as red in some websites or in some particular pages. But any which ways, we will just skip over this piece and also check this bit, and yeah, it shows us red. Okay, that's done. So as seen, we have assigned two different colors, and okay, fine, this is RGB is red, and this is the website that I had gone to have a look earlier, and it showed me that it was red, which is okay with me. So truncated, okay, now doing the similar thing with the 500 observations, and again getting that same error, but if I go with 499, I will not. So again, seems to be something weird over here. I'm not necessarily sure. Now I've got 99 over here. It might give me error. You see, it's giving me an error with 99, and if I go with 100, it will not. So this doesn't necessarily make any logical sense. But any which ways, this is okay. So we'll just let that be for now and look at it later. Okay, there's few other things which can be done, but I'll skip over that for now. And you can also, okay, the edge attributes. Yes, we want to change the color of the edge attributes also. So it's not only the vertex that we want to change or the nodes, but we also want to change the color of the edge. Now what we'll do is, now in place of using this export function of or functionality of RStudio, which was helping us either create an image or a PDF file out of the graph plot, we'll go ahead and use an internal PDF device, and I will also track the time that this particular device takes to go ahead and create the PDF. Okay. Now let me see. This is the one which and this is the one which I've got now. IG96_1. Yeah. So what does this look like? And over here, this is now something which is a functionality of the PDF. Once I zoom into this particular document, which is a PDF document which is just 278 KB, it will not lose its resolution, and it will also probably show me the graph in a much more clearer manner, and sometimes it will also create the layerings of the graph in front of me. Now this creating the layerings of the graph in front of me is quite fancy. I'm not sure how this will get captured in the video that I'm recording, but if you were to do this yourself, this is some fancy stuff happening here. So we'll just let it be. What we'll do is we'll go back to creating another graph. This time we compare the time, and we see that the time taken is much more, and let's see why. So this one says IG_96_1. So let's go and see what is different with this particular graph. And this is the one. Okay, so this is different from what we got earlier. And why is it different? Because the data set being used is different. Now this is for my 500 observations data set, or for my 500 observations graph. So if you look at this is slightly different. It is much more structured, even though you can't make out much over here, but you can try and zoom in and then again scroll down and do. So what you see over here, these are individual, and see how it gets populated. This is the fancy bit about this, how it gets populated over here. But anyways, again, it's not very intelligent and not really serving our purpose. So let's again go ahead and look at something with slightly less dimensions, and let's look at our our graph and network with just 100 observations, and what we get is 0.44, and over here we had 3 seconds and 3.20 seconds and 1.31, and here we have just 0.44. So basically what happens is with this particular layout, that is layout Fruchterman Rheingold, if I pronounce that correctly, we should be taking less time. And with that, in which ways, we've got 0.44 over here for the 100 observations. And let's again look at the graph. Again, much more intelligent, much more legible to look at visually, but still not doesn't necessarily say much. We can't make out much how you would want the actual graph to be plotted. It's not happening. Let's again scroll down in the script. Now here we are changing the algorithm for the layout. We are going with something called Kamada Kawaii, and I have not necessarily gone ahead and researched as to what is the difference or why this is so. But this is supposed to take much more time as far as the system time is concerned. So let's see the wall clock time as to what it turns out to be. It is 14 seconds. 14.02 seconds over here as compared earlier to 0.44. And let's look at the graph, what it looks like. Now this is what it is, and this is for the initial data set. The shape is much more like a network, and if you can see over here right now what is happening, it's actually getting populated. When I zoom in or zoom out, it's getting populated. This is for the 1275 or whatever the initial data sets. For the 1295 observations, that is. Okay. Now coming down to the one which is here. No, 1 second. JPEG. Yeah, this is the one we want with 100 observations. And let's see how much time this takes. It is 2.72 in comparison to 14.02 earlier. And again, looking at the graph, much more legible. And again, it's extremely dynamic, so to say. It gets created, gets populated in front of you if you go ahead and scroll or do absolutely anything on the PDF file. Okay, enough of this playing around. You can also create a JPEG, nothing fancy there. What we want to do is we again want to create a 3D graph. A 3D graph of the entire the initial data set, and let's see what that looks like. So it takes its own sweet time. You can see it getting populated here. It is taking 8.04 seconds, and this is the 3D graph. It looks like some kind of a, I don't know, it looks like a human brain. Yeah, with this over here, the 6606 and this 4471 could probably be the spinal this thing. But anyway, so this again not very intelligent. You can see some of the edges over here, and you can read few of the things which are written over there. So it says Forensics League, Quartet, some kind of ensemble, drunk driving officers. Okay, that stands out for some weird reason. So anyways, the cross country boys, standard 8th probably. Yeah, so some of these stand out, but we don't necessarily get a very intelligent rendering. And let's look at this now, which is the 100 observations. Time taken is far less. It is just 1.54 seconds in comparison to 8.04 earlier. And let's enlarge this and have a look. Much better. Much better. You can see most of the labels. You can see most of the edges. You can see the vertexes also clearly, and this is where I'll kind of have to truncate this and get back to this at a later point in time. Thanks a lot for listening in.